Hypothesis test involving two population means using independent samples. Chapter 13. This lecture is going to cover another hypothesis test, one that we have two population means instead of one population mean, like we saw in the last three hypothesis tests. So Chapter 11 covered hypothesis testing involving one population mean. So, for example, a population mean was stated, and we tested our sample data to be either greater than or less than the population mean. In Chapter 13, we'll conduct hypothesis tests that compare two population means. A sample is collected from each population to test if the population means are statistically different. Some examples of questions that could be answered with a two-population hypothesis test. Is there a difference in the mean physical fitness scores of third-grade girls and third-grade boys? The population of physical fitness scores for third-grade girls will be compared to the population physical fitness scores of third-grade boys. So you'll have two populations, one for third-grade girls and the other for third-grade boys, and we'll compare the two populations. Will good day automobile tires give better average mile wear than good poor tires? So in this case, we're going to look at two populations again. The first population is data for good day tires, and the other population would be the data for good poor tires. Using the two populations, we're going to do a comparison and see if they're statistically different. To find out whether there is a significant difference between the two populations, we take a sample from each population and calculate each sample mean. There'll be two values for x bar 1 and x bar 2. So we'll have population 1 will produce a sample called x bar 1, and population 2 will produce a sample we'll call x bar 2. We find the difference between these two sample means. So difference meaning subtraction. We test if the difference is significant using the hypothesis testing procedure. The testing model we use in this kind of test is a sampling distribution of the difference between two sample means. So we keep seeing sampling distributions come up over and over and over again. The sampling distribution of the difference between two sample means is also a normal distribution. This is how we arrive at such a sampling distribution. We start with our two populations, population 1 and population 2. From population 1, we take a sample x bar 1 for the first sample. And from population 2, we take a sample, x bar 2. The difference between the sample means, or basically what happens when you subtract them, is denoted by x bar 1 minus x bar 2. So just simply subtracting the two sample means will give you the difference. If you consider every possible samples of a particular size, so this is one possible sample from population 1, but we know there are many other possible combinations of samples of a particular size. And the same thing with population 2. This is simply one sample, but we know there are many others. So if we consider every possible sample from population 1 and population 2, and we collect all the differences between the two sample means for a particular sample size, so all the possible differences x bar minus x2, x bar 1 minus x bar 2, what we have is a collection of numbers that we call the sampling distribution of the difference between two means. In short, we have the sampling distribution of all possible x bar 1 minus x bar 2. So remember, this is the difference between two sample means. X bar 1 minus x bar 2 is the difference. And you have, when you're looking at the sampling distribution, it simply is just a collection of all possible differences between x bar 1 and x bar 2, given all the possible samples that could be created from the population. So visually, you kind of have a situation like this. You have a population 1 and population 2, and these little clouds off of the population represent samples. Now you know that we can collect any variety of samples. Like we may have thousands of different samples that are possible out of a population. And then we have another 1,000 or so different samples that are possible out of this population. If we construct all the possible sample means from population 1, we denote that by x bar 1, and all the possible sample means from population 2, that's denoted by x bar 2, and subtract them, we get a difference d. Now that collection of D1, D2, D3, all the way out to however many possible samples we have, that collection is the sampling distribution of the difference between two means. The mean of the sampling distribution of the difference between two means is, in the past we've used mu sub x bar to denote the mean of the sampling distribution, or mu sub p hat. This is mu sub x bar 1 minus x bar 2. And the way we get its value is we take the population mean from the first population and we subtract the population mean from the second population. If the population standard deviations sigma 1 and sigma 2 for the two different populations are unknown, which they will be for our purposes, every hypothesis test today is going to have sigma unknown, we will calculate the estimate of the standard error using the sample standard deviation for each sample. And here is the formula for the estimate of the standard error. It's a mess. The symbol is S subscript x bar 1 minus x bar 2. It is the square root of n minus the sample size for the first population minus 1 times the standard deviation squared. You get the hint. There's a lot going on here. The sample sizes are n1 and n2. The sample standard deviations are s1 and s2. And combining the two sample results to calculate the estimate of the standard error is called pooling. I'm showing this formula now, but later on we are going to use our calculator to get this number, so we're not going to have to utilize the formula here. We do have to take note of the fact that we are going to use pooling. So we're using both sample 1 and sample 2 to get the standard error, and when we get to the calculator we do have to indicate that we're going to use pooling. The normal or t distribution. If the two populations are approximately normal, so if P1 and P2 are approximately normal and the sample standard deviations are used to estimate the population standard deviation, then the distribution of the sample statistic can be approximated by a t distribution. Now, like our hypothesis test where we don't know the population standard deviation, when we don't know the population standard deviation in this type of hypothesis test, we are going to use the t distribution. So in the very center of the distribution, you know it's not a normal distribution, but it still has a bell shape to it. In the very center, we have mu sub x bar 1 minus x bar 2, and it's going to be set equal to 0. And I will explain why it's set equal to 0 in a minute. But along the horizontal axis, you have all the possible values for x bar 1 minus x bar 2. So every possible difference between the two sample means is labeled on the horizontal axis. And in the center, x bar 1 minus x bar 2 for the mean is going to be set to 0. We'll use the same procedure that we used in Chapter 10 and Chapter 11 for conducting a hypothesis test. And now we'll test the difference of two population means in which the population standard deviation is unknown. The result of the hypothesis test will tell us if there is a significant difference between the means of the two independent populations. Many times we will refer to this test as a two-sample t-test. So, if we want to know if there's a significant difference between girls' and boys' fitness at the third grade level, we will conduct a hypothesis test and determine whether or not our sample results yield significant difference between our two samples. And if they are significantly different, then we can say the same about the population. So we're basically using our sample data to make a conclusion about the population. Okay, the null hypothesis, H sub 0, will always state that there is no difference between the mean of the population 1 and the mean of population 2. If there's no difference between the two populations, then when you subtract them, or look at their difference, when you look at their difference is 0. So symbolically, for HO, we're going to write mu sub 1 minus mu sub 2 equals 0. The difference between the two population means is 0. It basically implying that there's no difference between the two population means. So when we start a hypothesis test, we make the assumption that the two population means are the same. And then we proceed to try to disprove that by showing that they are very different. So when we state there's no difference between the two population means, we imply that they are both equal. And if we reject the null hypothesis, at the very end of the test, if our conclusion is to reject the null hypothesis, we state that there is a significant difference between mu1 and mu2. So the implication of rejecting the null hypothesis is basically saying that mu1 and mu2 are not the same. There is a significant difference between them. The alternative hypothesis could be that the mean of population 1 is less than the mean of population 2. If that's the case, we write this symbolically. H sub A, mu1 minus mu2 is less than 0. So if we subtract mu1 minus mu2 and we get something that's smaller than 0, it means that population 1 is bigger than population 2. I'm sorry. Population 1 is smaller than the mean for population 2. Okay, so smaller number minus a larger number will give us a value that's negative. So that's the case when we have an alternative hypothesis where we state population 1 is less than population 2. If population 1 is greater than population 2, the mean is greater, we have just the opposite. Mu sub 1 minus mu sub 2 is greater than 0. So when you take a number and you subtract something that's smaller than it, population 1 is bigger than population 2, you'll get a positive number. The last type of test is that population 1 is just not equal to population 2. And this is the test, I've touched on the idea of a not equal to test in previous hypothesis test lectures, but in this class I'm not going to ask you to understand how to do a hypothesis test like that. That kind of test involves two directions, both a greater than and less than. You could see it in the textbook if you want to learn more about that.